Hey, namaskar everyone, this is Shourov back again with a new video. So first of all, before beginning anything, I just want to wish you happy Janmashtami. So now let's get back to our point. So in this video, we are going to learn what are interfaces in Golang, because interfaces are one of the most key important thing in Golang, in the entire Golang actually. Okay. So without talking too much, let's get started. In the previous video, we have learned how to create structs and the methods of structs. But in this video, we are going to create the same thing, but we will also fall into a problem. And later on, we will anticipate that problem using interface. So let's create a new folder named day 15 and drag and drop that recently created folder in the VS Code itself so that it can launch it with the new folder. After that, let's open up the terminal to initialize a new Golang project by the following command, which is go mod init and the package name intf, which is just a fairy tale like short name of interface. In my opinion, you can name it as you want. So let's create a new go.main.go file and declare the package.main package and make the function called main. And as you already know, this function is going to be responsible for compile and execute all the project codes. Okay, now let's create the planet struct, and which is type struct, type the name of the struct, which is earth, EART is earth, and its type of struct, and it will have a name which is string data type, and habitable is going to be boolean data type, is habitable, let's make it is habitable, and is water is boolean, and amount is, or visit amount, let's say visit amount float 32 type. Okay, now if you don't know how to create structs and the ins and outs of structs, then I would highly recommend you to watch that video which I have made on structs of Golang, completely dedicated on it. Okay, and then we are going to add a method on this struct. To do that, we need to create a function in a similar way but without any name. Here the argument should be start with the name, how can I explain it, the first alphabet of the name of your struct, which is E in this case, and the type of that struct, which is earth. That's well. And the function, we know that how to create functions, we need to name that functions here, but as we are making it as a method of this struct, then we are not, for that reason we are not following that convention of creating normal functions, but instead we are declaring it like this without any name. And here we can declare the name of that method like details. Well, so this is it, details. This is this is the method name. Okay, it's available inside this struct now. So now let's see, planet, let's create a variable called planet details and earth, where the name is going to be earth, then habitable, true, yes, it's habitable, water. Is water available there? Yes, there is. It's true. The amount to visit Earth is 100. Now let's print it by importing the package itself called fmt and printing calling the function println, and inside this argument of this println function we need to send the planet details. It's now not available. Now let's run the command to run that main.go. Here you can see the details of the Earth is inside this planet details variable, which is now an instance of that corresponding associated struct. Okay, so now if you try to access the keys, the fields of the associated struct, then you will be able to see a simple method here, which is this details. That's nice. Okay, we can call it there. So let's work on it. If you don't know how to use methods, then you can watch my previous video on these methods. So this is the continuation of that video. Okay, so in this video we are going to fall into the problem, and then we will get back from that problem with the solution of interface. Fine, so let's see. This method will accept the name itself, name of the user, which is going to be a string type, and the offered amount, which is float 32, and if var details, okay, feedback is going to be a string, and we just declared it without any value so that we can reinitialize it, populate the value into that feedback variable later. So let's check if the e dot visit amount is less than or equal to offered amount. It means the initial value which is set at 100 to visit in Earth, if it's less than our offered value or equal to the and if they're the same, then only it should give the details of this Earth. Okay, otherwise it will give a feedback of sorry, we cannot show you the details in this amount, this offered amount. Okay, so let's fill it with feedback, initializing it here with fmt package, which has sprintf for print string functioning formatting. Here, hey, the s is the name, here name, the Earth, the planet, Earth, let's give the value e dot name, which is Earth, from it's coming from here, which is the value. Okay, Earth's details are habitable, it's true, and water, it's true. Basically T is accepting the Boolean type, water, that's okay. Then what we can show you is print ln feedback. Otherwise, if the offered amount is less than our initial visit amount, then it should print fmt t.print ln, we cannot show you the details in your given offered price. That's okay. So now if you call planet details, you will be able to call that function. This function is going to take first argument as your name, the one who is going to offer the amount. In this case, let's name that person Toby, and the offered amount is 900, which is obviously greater than 100, so it is going to execute this line, and if the value is going to be less than this initial value, then it will run this else part. So let's have a look. Here we go, and let's make it 10 and re-execute it. You will be able to see that we cannot show you the details at your given offered price. That's pretty well. So now let's fall into the errors. We can see that it is accepting these Mars things, and the method is calling, but we are going to create another function called explore planets. It will take the planet Earth, okay, and the planet Earth is going to call it directly here. This thing should be called here, and so the name also going to be here. Name is going to be string, offered price is float 32. That's well, and here we can place planet, not planet, name, as the planet is will take itself here. The name is coming from here, and the offered price the same thing. And instead of running this here, we are running it inside this common function, and let's run that common function, explore planets. It will take the planet details and the name, which is Toby, and the offered price is 70. So it will reject again because the 70 is the amount 70 offered price is less than the visit amount. Okay, so now let's make a situation where we are going to create another type. So let's copy it. This is going to be the Mars. It's Mars, another planet, and let's create the same function for the Mars too. In this case, the methods arguments will be m, lowercase m, and the type is going to be Mars here. I hope it makes sense. And let's convert the e to m, and here too m. That's good. Now what if I am going to change it as Mars instead of Earth? Then here you can see the explore details, explore planets is expecting the Mars to be here, because the explore planets is expecting here Earth. Sorry, my bad. It's expecting Earth, what we are passing here, not the Mars. The struct type is now different. So to handle it, we need to change the expected struct to Mars. Now it will work. But how many times? Let's say we are going to create another Neptune, then we again need to change this thing, right? So we need a common way to handle it. So that's why we here need to be something that can anticipate this problem. To do that, we will create interfaces. Let's create interface. To create interface, you need to assign the type, then the interface name. It can be Planeter, 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 and then interface itself, the keyword interface itself. Then it will take the common method name, which is details here. It's common for the Mars 2 and the Earth 2. So let's add it here. Details, it's taking a string name, a name argument, which is a string data type, and the offered amount, which is a float 32 data type. Same for the Earth method too. So this is the common thing. So let's come here, and here explore planets, where we are previously explicitly mentioning the exact struct type. In this case, we are going to replace it with our Planeter interface. And now this common thing, as this method is common in every structs, it's going to handle it automatically. So let's see it. We cannot show you the details, so let's make it 700. Here you can see the Mars details are okay. Habitable true, which is not true, it's false, and it is false. Water is not available there. As per my knowledge, I might be wrong, so I can see that. Now let's create reinitialize it Earth. See, there is no error because we're using interface, and it by interface we are using the common methods. Okay, true. That's great, man. See, that's great. If you now create another struct and its variable, let's test it out with Saturn. And this method of Saturn should be a argument to start with S, and the type is Saturn, and it should be S, Saturn's S. These are also should be replaced with S. Now that's it. If you now come here with Saturn and Saturn, let's make it inhabitable, but water is available just for education, just for testing purposes. Here you can see Saturn's details are here. Okay, so this is interface. It is really useful, and we are going to heavily use it in our next videos and the projects. And I am declaring I'm announcing a project in Golang right after ending the series, which is the basics of Golang. Then we will create a project, a mega project using Golang. We will develop APIs and we will handle a lot of things. We'll also learn Next.js and much more thing is built. Okay, so yeah, that is the use of interface, and we can also use it in different ways. Hope I will come up with new videos of interface later on, but this is the basic and bare minimum purpose of using interface in Golang. It's really powerful. We don't have any concept of classes in inheritance in Golang. Instead, we have interface, and it has another option. Approach to handle. Like, let's say var name or anything is a variable which is declared as string. Later on, let's say we are going to initialize this variable, assign the variable with the value Shourov, which is completely okay. Anything, and fmt dot print ln anything okay. So now let's see, it's showing us this Shourov, but what if we change this to 13? Then it's telling us that the anything should assign only string, nothing else. What if we start giving the value of struct, then it's also going to show us some errors as well here. So to anticipate them, oh my bad, before this, okay, whatever, to anticipate this, what we can do, let's say a slice 3. Okay, so they are hard, you cannot expect a type found this, okay, this bullshit. So how to make it dynamic? So let's use interface. Oh my bad, interface with this curly braces. Now let's add it, I guess. No, not like that. 12, now 12 is assignable here. See, 12 is assignable. Let's make it change the value to Shourov, which is a string. It's also working. It's a string data type, and that's going to be for okay. Oh my bad, it should be here, the string type should be here. I was a fool. Okay, so now you can see we are also in assigning a slice here, then let's give it the value, it's a array now. See, everything is going to is acceptable here just for interface data type. So this is another one of the cases of using interface, but most important thing is that we have covered that in the rest of the video from the beginning, what we have just covered. Okay, so that was it. I hope you enjoyed this video and got a clear idea of Golang interfaces. And yeah, thank you. Happy Janmashtami. May Lord Krishna bless you all, and thank you. Goodbye.